11.3 Solving linear systems by adding or subtracting. Another name for solving linear systems by adding or subtracting is the elimination method. And I just want to remind you that a system is two or more equations. So we need to see two or more equations when we have a system. And then what we're going to do is we're going to use the elimination method in this section. Here are the steps for the elimination method. Step 1. Add or subtract the equations in order to eliminate one of the variables. Now, one of the main goals is for you to eliminate one of the variables. That way, only one variable remains. And then, solve for the other variable. Substitute the value of the variable you just solved for into either original equation in order to find the value of the eliminated variable. And then step 3, write the solution as an ordered pair. You will know that you have one solution when you have 1 point, x and a y. That means you're going to find an answer for x, you're going to find an answer for y. You're going to be able to write it as a point. And last, your lines intersect. Here's an example of two lines that are intersecting. And you can see that the solution is 1 point because the only place where both lines touch is that 1 point. And remember, you're going to have it as a point x comma y. The second type is when you have no solution, and in this case the lines would be parallel. They would have the same slope but different y-intercepts. Your slope is the letter M and the y-intercepts are your letter B. All your variables would cancel. You would end up with a false statement, for example 0, and you're ending up with 0 because your letters are canceling. So since they're both canceling, it's a 0. And you're going to have equals some different number. Of course, 0 is not equal to 5, so that's why this would be a false statement. It's not equal to 5. And as you can see here, the blue line would be parallel to the pink line. In the last situation, you have many solutions. This would mean that you have the same exact line, which would mean that they have the same slope, which is your M. They have the same y-intercept, which is your B. And what would happen when you're doing the math is that your variables will cancel and you will end up with a true statement. For example, you will end up with 0 equals 0. You're getting a 0 on this side because your variables are canceling. So it's a 0. And you're getting a 0 on the second side because your numbers also canceled. And when you're graphing, you're going to graph the blue line. And when you graph the pink line, you're going to end up finding out that you're going to graph it right on top of the blue line. That means the pink and the blue are actually touching everywhere. And so that is why we have many solutions. Remember that one solution is when you have 1 point of intersection, like this. Now, in the many solutions, you could see that you're going to have many points of intersection. Just like this. Now, remember that lines go forever, so there are many points of intersection, and there's even points of intersection between these points, and of course, all along this line. And since lines have arrows at the end, that means that you'll keep having points of intersection this way forever, as you will have points of intersection going this way forever. Let's go back and review. In this our first problem. So in this problem, we can see here that these two variables would cancel out. So since I'm able to cancel at least and eliminate one variable, then that means that I don't really need to change either one of my equations. So we're going to cancel. So these two are going to cancel here, leaving me with negative 2y. Okay, if I have 1y and I take away 3y's, then I owe 2y's. And if I owe 3 and I owe one more, so I owe 3 and owe because it's negative, and I owe one more, then that means that I owe a total of 4. Now, since this is a negative on this side and the second side is also a negative, then that means that if I divide by a negative 2 on this side, on the left side, and I divide by a negative 2 on the right side, the negatives actually cancel. So you'll see here how the negatives cancel and the 2's cancel. The negatives cancel, and I will end up with y equals to 2. Now, since I got an answer for y, that means I'm going to have one solution because none of my variables canceled, so I already know I'm going to have one solution. You cannot have two solutions. The reason why you can't have two solutions is because you're not going to have one line cross and then the other line cross, and they only cross once. You can never have a line come back and U-turn and come back and cross again. It just doesn't happen. Now, if you go take the y into one of your original equations, so let's go take it into the bottom equation. Let's use the bottom equation, or actually we'll use the top one. We'll get negative 5x plus whatever y is, which we're going to plug in right now, equals to negative 3. So what I did was I recopied that equation, the first one. I just recopied it with the y blank. Now I can substitute the 2 that I found earlier into the equation, and now I can solve. So let's solve this equation. So since I have a plus, the opposite of adding is subtracting. So I'm going to subtract 2. And what I do to one side of the equation, I must do to the other side of the equation. And you can see the numbers go together. So these are going to cancel. I'm going to bring down the negative 5x, and I'm going to get an equals to negative 5. Why negative 5? Because I owed 3 and I owed 2 more, so now I owe 5. Now, since I have 5's on both sides, I'm going to divide by a negative 5 on this side. What I do to one side, I do to the other side. So these cancel, so do the negatives. I end up with x, because I'm going to bring down the x, equals to, the negatives cancel, and 5 goes into 5 one time. So now I know my solution. My solution to this problem is x, which is a 1, and my y, which is a 2. And this is my solution, that point. The point where the lines cross or intersect. Let's go to number 7 also. Okay, so on number 7, you can see here that these two numbers are not the same number. So if I were to add these x's, I would get negative 3. I don't want that. I want them to cancel. Now, you can see on the y's, they look alike. They look very alike. But if I were to add them, I have 1y, and I have 1y, and 1 plus 1 is 2. So I'm not getting 0. They're not canceling out. And so in this case here, I need to actually change my problem a little bit. So I'm going to change the bottom equation by multiplying everything by a negative 1. Now, a negative changes all my signs, but the 1 multiplying by 1 is not going to change any of my numbers. So we're going to change both the first equation is not going to change at all. So I'm just going to rewrite it, but I'm going to change the bottom equation. So the bottom equation is going to be negative 1 times negative 5 is going to give me positive 5x. Negative 1 times positive y is going to give me negative y. And negative 1 times 8 is going to give me negative 8. Okay, once I add them together, now I'm going to add them. So we had to change this first equation. So what do? We changed the equation to help us. And then we're going to add our equations together. So 2 plus 5 gives us 7x. And y, take away y, actually makes our y's cancel out. That's eliminating one of the variables. I'm going to bring down the equal sign. Bring that down. And then if I owe 6 of whatever it is, and I owe 8 of whatever, then now I owe 14. So the next step would be for me to divide, because I'm going to solve. So your next step is to solve. And we are going to divide both sides by 7. And that's going to give us x is equal to negative 2. So I know again that I'm going to have one solution because I got a value for x. So if I come back to my original problem, I'm going to go to the top equation. 2 parentheses plus y equals to negative 6. Now I left the parenthesis blank because I am going to substitute that negative 2 into the blank. So negative 2. So negative 2 times 2 is negative 4 plus y is equal to negative 6. When I solve, in this case, I'm going to add 4 because the opposite of subtracting is adding. And I'm going to add 4 to the other side. So what I do to one side, I must do to the other. These cancel out, leaving me with y equals to negative 2. So my solution is for x, I got negative 2, and for y, I got negative 2. And no, you don't always get the same numbers, because you can see that in this problem, these x's and y's were not the same number. Here, they ended up being the same number, but that's just by coincidence. The next problem I'm doing for you is number 10. I know that number 10 looks difficult, but it's actually a very easy problem. You can see these variables here. They're both x's, and I have a 1/2, and I have another 1/2, and I have one being positive, and I have one being negative. So if I read it correctly to you, it would be I have 1/2 x, and I'm going to take 1/2 x away. Now what happens to those two? They cancel. Let's go look at the next set of variables. I have both y's. I have both 7/9, so they're the same exact number. I have one positive and I have one negative. Now when I have one positive and one negative of the same number with the same variable, then that means they eliminate. They also cross out. They're gone. So that means that this whole side of the equation is a 0. Here's my equation, my equal sign. Now, I cannot add the next one unless I have to either change the top fraction or I have to change the bottom fraction. Now, I'd rather change the bottom fraction. I want them to look alike because, see, this is an improper fraction. I have the top number being bigger than the bottom. That's improper. When it's proper, these would be proper. The top number is smaller than the bottom. That's a proper fraction. This fraction is improper. And 6 and 2/3, that's a mixed fraction. So I have an improper fraction that I'm trying to add with the mixed fraction. I can't do that. They have to be in the same form. So what I like to do here is what I call around the world. So we're going to go around this fraction and come back to the 3 when we're done. So when you do this first step, it's going to be multiplying, and the top step is adding. So let me walk you through that. Okay, so 3 times 6. 3 times 6 is 18. Keep that number in your head, 18. 3 times 6 is 18. 18 plus 2, so you add the top number, plus 2. So 18 plus 2 gives me 20. So my fraction turns into 20 over, now I said I was going to go around the world. So when you come back around, that same denominator, the same denominator stays at the bottom here, denominator. So that's 20 over 3. Now, when we look at this problem, you can see that, hey, I had negative 20 over 3, and now I have positive 20 over 3 because these two fractions are actually equal. I just made them look different. Made it look different than it was. But these two actually cancel out also, leaving me with 0. Now, we can come back to the... Okay, and let's remember that if we had a true statement, which this is true, 0 is equal to 0 all the time. So since we are getting a true statement, this means that we have many solutions. That means that these two lines, when they are graphed, they're actually, one is on top of the other, and so they touch everywhere, and that means that they have many solutions. Okay, now let's go and try number 13. So on number 13, you can see again that these cancel, giving me 0, and 0 plus 0 gives me 0. So once again, I have a true solution. So that means that I have many solutions. I don't just have one, I have many. Okay, now I know that sometimes your word problems look a little bit difficult, but really in reality they're not. Okay, we have a rectangular garden. That means you need to draw a rectangle. Whenever they're asking for shapes, you're better off just drawing them right away. Okay, the perimeter, that means I'm going to add up all my sides. When I add up all the sides, it equals 120. The length of the garden is 24 feet. So 24 feet greater than 2 times the width. Okay, that's the length. The system of linear equations here is representing this situation where L is the length of the garden and W is the width of the garden. Find the length and the width. Now, since L is the length and W is the width, all I need to do is find L, which will be the length. So when I find that number, I'm going to put that there. And W, which is the width. And when I find that number, I'm going to put it here. Okay, now you can see in the problem here that if I were to add these, I would get 3. They do not cancel. But if I add the W's together, those cancel. So I'm going to go ahead and cancel those. Now here on the L's, I told you earlier that it was 3. So 3L is equal to 120 plus 24 which is 144. Okay, so if I divide by 3 on both sides, I'm going to end up with L equals to 48. So I have my L now. So I can put that answer right here. I'm bringing that 48 for the length, and I'm going to write that right there. So my length, I know it now, it's 48 feet. That was easy enough. Now to find my width, I am going to need to take that 48 and transfer it either into my first equation or into my second equation. Now I think it would probably be easiest to plug it into my second equation. So that's exactly what I'm going to do. So I'm going to rewrite my equation here. L plus 2W is equal to 24. And I'm going to substitute the L in here. But I did make a mistake on writing that equation. So I'm going to rewrite it one more time. Okay, so, and I'll switch colors too. Alright, so L minus 2W equals 24. I'm going to substitute that 48 in for the L. 48 minus 2W equals 24. Now, it would be very easy for me to subtract the 48 from both sides. So we're going to subtract the 48 to this side. So negative 2W equals 24 minus 48. So negative 2W equals, and don't forget that negative here. See, that negative is going to follow along with that 2 because I have not subtracted, I haven't divided. Remember, these are multiplication, so I would need to divide. So now this is negative 24. If I divide by negative 2 on both sides, then I'm going to end up with W equals 2. Negative and a negative become a positive, and 24 divided by 2 gives me the number 12. So now I know my width, and I'm going to take this width and write it up here. So my width is 12 feet. And these two here are my solution to that problem. The last problem that I decided to do with you is number 21. And this has to do with a pool company. And they're installing a rectangular pool. Again, that's a rectangle. And you can see the rectangle here. Okay, I'm going to highlight it on the picture for you. Here's the rectangle. So now you can see the rectangle. Try and make it darker. Okay, so here's the rectangle for you. It's a rectangular pool, and the construction workers are making it at the moment. Okay, so let's go look at what else they're telling us. They mentioned that the perimeter of the pool is 94 feet. So if I add all these sides and I measure, kind of like if I was going around with the measuring tape, it would measure 94 feet. And the length has to be 2 feet bigger than whatever this size is, which is the width. So this has to be 2 feet longer than this side, than twice this side. So basically I'm taking 2 of these, which is the width, plus 2 more feet. That should measure the length. So in the system of linear equations, it's actually representing what they're saying here. They're already representing it here for you, okay? And you can see the length is equal to 2 times the width plus 2 more feet. On this one here, this is the actual formula for finding perimeter, because if you're doing perimeter, don't you have two lengths? So we have two lengths plus we have two widths, and if you were to add those together, the two lengths plus the two widths, then it would give you the perimeter, and they told you what the perimeter was. The perimeter is 94. So basically these two equations represent what's up here. And we need to find the L and the W. And what are the dimensions? The dimensions are just your length and your width. So you have two dimensions, a length and a width. If we had a height for this, which we do, it goes down, it's a depth, then that would be a third dimension. So each time you add a dimension, it would be like this. Okay, so now let's actually work out these two equations. So we have 2L plus 2 width equals 94. And I need to have my variables on both sides, so I'm going to keep the L where it is. But what I'm going to do is I'm going to move the 2W to the other side. Now, remember, if I move this, it's going to change signs. So it's a positive here, but when I move it, it's going to become a negative. So I'm going to have negative 2 width. And this 2 here, I'm going to keep it where it is on the right side. So I'm going to keep it here. So it's still positive 2. Now you can see that, what's going to happen. So you can see that these two are canceling out. And 2 plus 1 is 3. So 3 length. And then these canceled, so equals. And 94 plus 2 is 96. So now I'm going to divide. So I'm going to divide both sides by 3. And I'm going to end up with L is equal to 32. So I basically know that this length is 32 feet. Let's find our second length, our second dimension. So I'm going to substitute into this equation, the second one. So L is equal to 2W plus 2. So I'm going to take the L and I'm going to plug it in right here. So instead of writing the L, I'm now going to write the number 32. And then 2 widths plus 2. And I'm going to work on solving that. So I'm going to subtract 2 on both sides. And these are going to cancel. I'm going to end up with 30 equals to 2W, 2 widths. And then I'm going to divide by 2 on both sides. And that means my width is equal to 15, because 30 divided by 2 is 15, or half of 30, right? Dividing by 2 is half. You're cutting it into 2 pieces. Half of 30 is 15. So we actually know that this length here, this width, is 15 feet. So now we know both dimensions. This is the length. This is the length. And the second one is the width. And we have solved for both of the dimensions. Okay, I hope that the problems that I did for you helped you. And please make sure that if you have any questions, ask in class.